Let's discuss the question number 28 from test series 4. This is from thermodynamics. Okay, so what is given? A fixed amount of air initially at 1 bar and relative humidity 40%. So basically you have imagine that you have a container, or it can be normal air also, air plus water vapor. Okay, and that is at a relative humidity of 40%. Okay, so relative humidity and at temperature T is compressed isothermally until the onset of condensation. So it is compressed but temperature is constant, okay, such that the condensation occurs. So this can be understood like if you remember this chart for TS diagram. Okay, so you have the water vapor state somewhere here. Okay, and now it is compressed such that condensation occurs. So this is P1 and this is P2. So at this temperature, so the water vapor initially here, so this is basically, this process describes the state of how the state changes. So water vapor initially it is compressed at constant temperature and such that its pressure increases, and as its temperature increases, as its pressure increases, at this temperature it reaches the saturation pressure, and so it starts condensing. Okay, so now, so this P1 by P2, or in fact P1 by P2 I am calling as PS, so let's call P1 by P2 or PS at that temperature is basically my relative humidity, which is 40%. Okay, so now initially at state 1, because it's a mixture, the air pressure is PA and the water pressure is P1, so that combined is my mixture pressure. Okay, and that is nothing but 1 bar, so mixture pressure is 1 bar. Okay, and the mole fraction is given is 60% at start. So mole fraction is basically my P1 by PM, I mean the water vapor pressure P1 by the mixture pressure, that is nothing but the mole fraction, or I can write mole fraction as J, and that is 0.60. so P1 is PM into 0.6. PM is mixture pressure initially, which is 1 bar, so it is 0.6 bar. Okay, now at state 2, that is, it starts condensing, the vapor starts condensing. Okay, so at this state 2, what happens? At this state 2 also I can write, let the water vapor pressure be PS, because it starts condensing, so it reaches the saturated pressure. The air pressure is PA, and that is nothing but the air pressure changes, PA dash, and I have PM dash. Okay, so ultimately what I need to find out is, I need to find out PM dash, but I know that the mole fraction just at the onset will be same. At the onset of condensation it will be same. So my vapor pressure, which is PS, by my mixture pressure, which is PM dash, will be again the mole fraction, which is 60. So I need to find out PM dash. So PM dash is PS by 0.6. Now PS, how do I relate? Now, PS, I have the relative humidity, which is given as PS is equal to P1 by 0.4. So I'll use this thing, and P1 already I got as 0.6. So PS is nothing but P1 by 0.4 into 0.6 here. This 0.6 is there. Now P1 I got as 0.6. So 0.6 by 0.4 into 0.6. So this is 1.4. That is nothing but 2.5. So the mixture pressure, the new mixture pressure is 2.5. So the answer is D. Option is D. Thank you.